Hello everyone, it's Cristan here, and this is the second part of this week's training looking at fractions, decimals and percentages. This time we are looking at progression in lower key stage 2, and this training has been very kindly put together by Cristan, the maths lead at High Lane Primary School.
This video will introduce you to fractions, decimals and percentages in lower key stage 2. Here is an overview of how the concepts of fractions, decimals and percentages has begun in key stage 1 and also what is expected in lower key stage 2.
It's really important to bear in mind what the children already know when they get into year 3 and 4, because this shows you the starting point for their knowledge.
This part shows you what needs to be taught when the children then progress into upper key stage 2.
So again, it's also important to know what the children will be taught in 5 and 6, because it's vital that we remember to master the concept as opposed to push into the next year group.
This slide explores the vocabulary associated with fractions, decimals and percentages. It is vital that the children understand and use the correct vocabulary.
So as we looked at in the previous video, we now know that children should know what a fraction is, know what a numerator and what a denominator is. And in 3 and 4, we're beginning to look at the different types of fractions.
Children now should have a good understanding of fractions and what they represent. In year 3, we show the children that fractions, division and multiplication are closely linked. A fraction represents how many parts something has been divided into, so we can use a fraction to help us to divide an amount. We must reinforce the vocabulary regularly. For example, here we are showing the children that the denominator is 3, so the 9 circles need to be grouped in 3s. Therefore, the question is 9 divided by 3. Now we look at the numerator to decide how many groups of 3 are which colour. We can see the numerator is 1, so this means each team has 1 group of 3. On this example, we can see the bar model being used. The top bar is the whole. The denominator tells us the number of parts we split the whole into. This tells us the value of each part, which we then multiply to find the total value of the whole.
So as we can see on this example here, so if a quarter of a number is 8, we can put the bottom bar split into 4 pieces, each piece representing a quarter, which is worth 8. So we then know that we need to multiply 8 by 4, because there are 4 parts in a quarter to make a whole, and 8 multiplied by 4 is 32. It's a really nice visual representation of fractions.
We now ask the children to start transferring their skills. We move from fractions of shapes and quantities to placing fractions on the number line. Step 1. Split the rectangle into 4 equal parts. Step 2. Draw a number line alongside of the rectangle and split the line into 4 equal parts. Step 3. We can see the 4 equal parts and the 1/4 is labelled. Step 4. 1/4 is 1 part away from 0. Now we have mastered halves and quarters, we begin introducing thirds, splitting a whole into 3 equal parts. Again, we can do this with shapes, objects and pictorially by jottings. Now we also include tenths into our understanding. We just divide a whole by 10 equal parts to create tenths. This can also be shown as a decimal of 0.1. We need to explain to the children that the decimal signifies part of a whole. We can have multiple tenths. It is the numerator that increases. The denominator stays the same as a whole. It is still split into that number of parts.
It's really important at this stage that children begin to see the relationship between fractions and decimals. So they can see that 1/10 is equal and the same as 0.1.
We can start to explore processing and calculating with fractions to make a whole. In this example, 9/9 would make a whole. So if we have 4/9, we would need 5 more 9s to make it whole. In year 4, we begin to learn about ordering fractions. To order fractions, numbers or measures on a number line, first of all, work out the total value of the number line. Count how many equal parts are on the number line. Then work out the value of each equal part by dividing the total value of the number line with the number of equal parts. The final step, label each part appropriately. In this example, we split our number line into 10 equal parts, and therefore each part has a value of 1. This number line has a total value of 1. There are still 10 parts, and so the value of each part is 1/10, which is also the same as 0.1. We can show fractions in different ways. Number lines are a useful way of showing equivalent fractions. Equivalent fractions are fractions that have the same value, although the denominators and numerators are different.
Quite often at this stage, children will be able to use a fraction wall to help them visualise the equivalent fractions.
We order fractions on a number line in the following way. Ensure that the denominator is the same for each fraction. Look at the numerator in each fraction and use this to arrange the fractions in either ascending or descending order. We must look carefully to see if there are any numbers already on the number line and order accordingly. For this example here, the denominator for each fraction is the same. We look at the numerator and order in ascending order. We order whole numbers on a number line in either ascending or descending order in the following way. We look carefully at the numbers already provided on the number line to ensure we put them in the correct place. We carefully check the value of each part of the number line. On this example here, can you place these numbers in the correct places on the number line?
So that's a good example of the kind of question that a child would get to order the numbers on a number line.
We have previously looked at 2/4 being equivalent to 1/2. Now we extend this to other equivalent fractions. We can show fractions in different ways. A fraction wall or grid squares are a useful way of showing equivalent fractions. Equivalent fractions are fractions that have the same value, although the numerators and denominators are different. Equivalent fractions can be shown using grids of squares as well as fraction walls. This shows one whole being divided into quarters. If we shade 1/2 of this shape, we can see how many quarters equals 1/2. By now, the children are familiar with tenths. We progress onto hundredths. We explain this as 1/100th is 1 part out of 100 equal parts. This is something that can be modelled to the children like these examples here.
It's really important that when we begin to show them in representations of decimals that we label the place value headings so children have got a really clear understanding of what it looks like and what it means.
Next, we begin to calculate with fractions, starting with adding fractions with the same denominator. This is introduced pictorially, like the examples here. Then we look at subtracting fractions with the same denominator, like this example here.
So when we're adding and subtracting fractions with the same denominator, we add or subtract the numerator. The denominator stays the same.
As the children become familiar with tenths and thousands, we begin to make the explicit links between fractions and decimals. Here we can see 1/10 is 1 equal part out of 10 equal parts. So 1/10 would look like 1 in the tenths column. We put 0 in the ones column as a placeholder. We can transfer this understanding of tenths and hundredths. For example, 1/100th is 1 part out of 100 equal parts. As you can see, it is very small when compared to 1 whole. So the 1/100th would look like 1 in the hundreds column. We put 0 in the ones and a 0 in the tens column to provide placeholders. As the children become more confident with decimals, we can introduce decimal equivalents for 1/4, 1/2 and 3/4. To ensure the children remain confident, revert to pictorial representations so they develop a secure understanding that they need. By now, the children will be competent to count up and down in tenths. We are going to use this to introduce rounding. Rounding is when we say which whole number is closest to our decimal number. In these examples here, we can round 1.3 to the nearest whole number. You can see here that it is closest to 1 on the number line. This is a tricky question as it is exactly halfway between two whole numbers. So we have a little rule. If it is in the middle, it is always rounded up to the largest number. For example, 1.5 rounds up to the nearest whole larger number. Therefore, 1.5 rounds up to 2. Finally, in Year 4, we look at comparing numbers with the same number of decimal places. For example, 100th is 1 part out of 100 equal parts. As you can see, it is very small when compared to 1 whole. When we increase the number of hundreds between 1 and 9, the digit in the hundreds column will change. For this example here, it's 0.02. If we have 10 hundredths, this is the same as 1/10. This is shown pictorially here, using a 100 square and also the 10 sticks. 11 hundredths, or 0.11, is the same as 1/10 and 100. Thank you for watching this video. I hope you found it useful. If you need any further assistance, please contact me on the email on the screen.
Thank you very much for Cristan for putting this together. It's been extremely informative.